Hello and welcome to VitoshAcademy. Today we are driving into the fascinating world of the sine function, and you'll see how the sine connects triangles, the unit circle, and key angles like 30 degrees, 45 degrees, and 60 degrees. By the end of this video, you will have a deep understanding of how sine works and how it relates to geometry and trigonometry. So let's jump right in. Starting with the basics, here on my screen I have a right triangle where actually sine is defined for the right triangle, so it is defined as the ratio of the opposite side to the hypotenuse. So this makes sine as key tool for connecting angles to side length in geometry. Just visualizing this concept with a triangle of 30 degrees, if we take this one here, 30 degrees, it means that the sine of 30 is actually half. So what does it mean? We said it is ratio of the opposite side to the hypotenuse. So this is the opposite. It's obviously 1 and the hypotenuse is 2. So you see that sinus of 30 then is 1 over 2, or it means that whenever we have in the right triangle 30 degrees, then the side in front of this angle is half the hypotenuse. And here is how the code for this one works. Here I am simply defining the coordinates. Plotting the triangle is rather easy. Annotating the sides I had to play a bit, and this square of 3 is unfortunately the way it should be, otherwise it's a really ugly number. Annotating the angle, this is a 30, so this is a 90 degrees, so obviously this one is a 60, but I'm only writing the 30 here. And another key thing is this axis, it should be equal. It means that 0 to 1 is the same as 0 to 1 on x and the y. So far so good. This relationship, as I mentioned, holds true for any triangle with a 30-degree angle. Yeah, no matter its size, pretty much. Whenever we have the 30-degree angle, the hypotenuse is always like double the opposite side when we have like also a 90-degree triangle. Let's talk about the unit circle. So this way we will extend the concept of sine to the unit circle, and the unit circle is pretty much a normal circle that has a radius of 1. Just this way it should be easy, and it's centered at the origin. So on our XY scheme, the thing is here, the center. Yeah, and here the sine of the angle corresponds to the y coordinate of the point where the terminal side of the angle intersects the circle. And we will animate the concept. First, I'm going to plot the whole code here. It's not going to be animated, but I'm going to run the animation soon. So this is how the plotting works. This thing is going to be moving, the red dot, like this. And here is where you should concentrate actually, because this way you would see how much the red dot is moving and how exactly the sinus is changing, and the opposite side length is also changing, so to say. For example, when we have like 30 degrees here, then the opposite side, which would be pretty much this one, would be half the hypotenuse, and here the opposite side length should be 0.5. Let's try to run this one on Python. So running it happens with a simple execution of a code, and this is how it happens. Okay, so we are waiting for 0.5. We just passed it, but somewhere here, if you wait to see the 0.5 here, then you'll see that this side was half the hypotenuse. And we have 0.5 actually 4 times. I'm talking about the opposite side length. It's going to be 0.5 soon again. Yep, it just happened, and when the 0.5 was here, it is going to happen. Okay, so pretty much this is sine as a triangle of the unit circle. It's actually really interesting once you realize how it happens. For example, this is the reason why sinus is 0 whenever we talk about 0. It is, yeah, because the opposite side is actually going really towards 0, and the hypotenuse is going through 1. So yeah, that's why it's 0. And here, whenever it reaches 1, the idea is that absolutely here, the opposite side and the hypotenuse are matching each other, so that's why it is 1. So yeah, this is how it is. Let's talk about now the sinus for 30, 45, and 60 degrees, which is a bit more interesting. And I also have prepared the code, so you do not see me typing for like 10 minutes, wasting the time. I'm just going to explain a bit. Pretty much this is the function to plot the triangle, and we have 30 degrees, 45 degrees, and 60 degrees. Let's see. So sinus of 30 degrees, here we have the hypotenuse and we have the opposite. Pretty much this is the same as this one, but we had to start with the important sinuses. And then we have the 45 degrees, and sinus of 45 degrees is 1 over 141, pretty much. And sinus of 60 is 173 over 2. Yeah, this is how it goes in our case. Pretty much. With other calculation, for 30 degrees, the sinus is 0.5, as I mentioned, 1 over 2. For 45 degrees, it is squared 2 over 2, or 1 over 141, which should be 0.71. Let's calculate it. 1 over 1.41. Yep, it's close to 0.71 if you take a look exactly. And then the third one for 60 degrees should be opposite, is 1.73, and the hypotenuse is 2. So it is 0.865, so it's 0.87, which is squared of 3 over 2. So this is how it is. In this really quick video, I mean, hopefully less than 10 minutes, we explored the sine through triangles, the unit circle, and key angles like 30, 45, and 60 degrees by connecting geometry and trigonometry. So this way sine becomes really a valuable tool. Thank you for watching, and just before we leave, I'm going to give you the sine function, because it's a bit unfair to talk about sine and not seeing the sine function itself. So I'm going to plot it as well, and then we'll say. So the sine function itself, pretty much in order to display it, we will be talking about sound wave data, because the sine has really smoothly oscillates, just like the vibration of a guitar and the compression of air in a sound wave. So just to generate it, this one, and to see how it works, we have this code prepared, and this is the generated sine function of a sound. Because sine doesn't just live in maths, it's essential in physics, engineering, computer graphics, and it helps to model waves like sound waves, light waves, radio signals. So this is the sine function with radio waves, and the simple sine function looks like this. Pretty much this is the code, and this is what we see. And we have the x values and we have the y values, and pretty much sine function is a repeatable function without an end, and it is generated between minus 2 pi and 2 pi. So minus 2 pi is here and 2 pi is here on our end. So this way we capture the two full cycles of the sound wave, of the sine, not sound wave. And then on the x-axis, pretty much we have the pi formatted labels, which is like minus 2 pi, minus pi, pi, 2 pi. And the grids are nice, pretty much. And whenever we talk about sine function, you should always think about this thing. I mean, if you start between 0 and 2 pi, this is just one tiny cycle, and in our case we have two cycles. So yeah, 0 to 2 pi, this is the sine function, and this is how it looks like. Okay, so far so good. Thank you for watching, and let me know whether you like this video where I'm almost not writing code but mainly explaining the things as I see them. Enjoy the rest of your day or night. Take care. Bye bye.